Okay, so we have also here the other, okay, the site that would eventually be avoided. So we have the burn, the damage, the scar, occluded. Okay, so eventually you need to prevent that one or to avoid that one, like in the case of your burn, damage, scarred, occluded. Pag scarred and occluded, scarred, for example here, so, because again, pag scarred siya, so, the blood flow here in that area, hindi siya ganun ka-effective, and therefore it will have here, hindi siya ganun magiging ideal site for extracting the blood sample. We have also here seizures and tremors. So basically, you need to stop the venipuncture, vomiting and choking. Also, you need to stop. So wag na natin, baka naman na while you are extracting the blood, so since na hindi pa siya tapos or hindi pa enough ang blood mo, so sabihin mo, wait, gano'n. But again, if you try to encounter vomiting, seizures, then you need to stop. Allergic reaction could also be encountered with the blood extraction. But of course, there are some patients naman that they will tell you if they have certain allergic reactions to the materials that we use during the blood extraction, like allergic reaction to your micropore tape, to your tourniquet, to your gloves, and all of that. So kung lahat na lang allergic siya sa lahat. Okay, so, okay, just sabihin mo na huwag ka na magpakuha ng dugo. Like, allergic siya sa tourniquet, sa gloves, sa micropore tape, sa cotton ball, sa cotton, sa alcohol and all. So, okay, huwag na lang, gano'n. Now, we have here the mastectomy. So, mastectomy here is a process whereby the breast is being removed because meron siyang tumor or cancer for that. Okay, so our rule here also applies with the mastectomy, the same with the IV line. So wherever the mastectomy or the breast is removed, you try to extract on the opposite side. I mean to say, if the breast removed here on the right side, then you try to extract on the left side. But then again, if two breasts has been removed, so paano yon? Okay, so just extract here at the hand of the patient. Do not apply tourniquet. And then, basically, that's to prevent here the lymphostasis. Kasi pag na-remove ang breast, most likely the lymph nodes, along with that, has also been removed. Remember that your lymph nodes, part of your secondary lymphoid organ that helps our body fight against the pathogen. So since na-remove siya, it might have the tendency here na if you try to apply tourniquet, for example, it might accumulate the lymphatic fluids and highly painful din siya. So again, tourniquet application is not applicable for that. And then, kung dalawang breasts ang na-remove, then try to extract in the hand area without tourniquet application. Okay, then when we are collecting the blood, so make sure that you try to mix the blood here with your anticoagulated tube. Okay, so you should have your adequate mix in the blood containing here the anticoagulant. So pag nag-mix tayo, pag ganun siya, ganyan, tas isa, ganun. Hindi ganyan isa ha, pag pagbalik mo, das isang mixing ang count doon, dapat ganun. Ganyan, isa, dalawa, ganun. So majority of the tubes here would have 8 times mixing or inversion, but in the case of your citrate or your light blue here would have 3 to 4 inversions. Okay, now we go to the additives. So these are the chemical agents being added in our blood collection tubes. So the first one, we have here your anti-glycolytic agent. So from the words of anti-glycolysis, that prevent the glycolysis or the consumption of the red cell with your glucose. So this is ideal here for the glucose determination. So anti-glycolytic agent in the form of your lithium iodoacetate or your sodium fluoride. But your blood collection tube here could eventually be added with other anticoagulant like potassium eta, potassium oxalate. Kung ang tube natin contains here this one, sodium fluoride plus potassium eta, magiging anticoagulant and anti-glycolytic agent ang magiging action ng ating additives. Pero kung ang nilagay mo lang is sodium fluoride or lithium iodoacetate, so anti-glycolytic agent siya, hindi siya anticoagulant. Pero pag nag-add ka nito, potassium eta, potassium oxalate, it become plus this one, it become anticoagulant because ito yung mga anticoagulant, ito ay antiglycolytic agents natin. Another one na additive natin could be in the form of your clot activator. Clot activator try to enhance the clotting process, to speed up the clotting process para mag-clot siya kaagad ang blood natin that would allow you then to centrifuge and to collect the serum sample of your blood collection or your blood. Your clot activator may be in the form of your glass, could be your silica gel, or you could also have your thrombin. Okay, another additive that could be found here or could be found in our blood collection tube, we have your gel, separator gel, or you call that was your thixotropic gel. Again, this is the content of your yellow tube na may gel. So again, this is not equivalent to your blood culture tube na yellow top din siya because wala itong SPS. So your gel would eventually is an inert material that try to change the viscosity during the centrifugation process. It's also help you enhance the separation of your serum with your PRBC. So after centrifugation, ang gel natin makikita mo dito sa between ng serum doon sa taas and the PRBC nasa baba. This would also help you prevent the contact of your red blood cells with your serum sample. That would also help here then to prevent the glycolysis then. Another one, we have here your anticoagulants. So, anticoagulant prevent the clotting process. Dalawang mechanism na anticoagulant natin. One, act here as antithrombin. Remember the conversion of your fibrinogen to your fibrin clot. What we're needing would be the thrombin. So, kung wala kang thrombin, hindi siya magka-clot. That's why your heparin, okay, so it prevent the clotting process by acting as antithrombin. Sisirain niya or try to neutralize or inhibit the thrombin and therefore preventing the conversion of fibrinogen to your fibrin clot. Of all your anticoagulants, siya lang ang iba ang mechanism and how it try to prevent the clotting process. With the rest of your anticoagulants, so all the rest here we try to prevent the clotting process basically by destruction or neutralization of the calcium. Calcium is needed para magkakaroon tayo ng clotting process. Kailangan mo dito plus your thrombin. So all the anticoagulants, they prevent the clotting process basically by the action with the calcium. Again, calcium is needed for the clotting process. So kung tinanggal mo si calcium, sisirain mo si calcium, hindi magkakaroon ng clotting process. And those are the action of your anticoagulants like your EDTA, your citrate, or even your oxalate. But your heparin prevent the clotting process by acting as antithrombin. So we start here with the first anticoagulant. We have here the ETA or your ethylene diamine tetraacetic acid. So your ETA, we have here the anticoagulant blood ratio. Pag sinabing anticoagulant blood ratio, that's the amount of anticoagulant and another amount of your blood to prevent the clotting process. So dapat we need to observe the proper anticoagulant blood ratio to prevent the clotting process. So pag hindi siya pantay or you're not able to follow here the correct anticoagulant blood ratio, magka-clot ang blood natin. So for the ETA, that's 1.5 milligrams of the ETA is enough to prevent the clotting process of 1 ml of your blood. Okay, again, the basic action of your ETA that how we're able to perform here the anticoagulant property, try to chelate your calcium. So therefore, pag walang calcium, so wala tayong clotting process. We have here the different forms of ETA. We have the disodium ETA, your other name for the servercine. The dipotassium ETA is your dried form na ETA. And actually the one is being recommended here routinely to be used here as the blood collection tube for our routine cell count by International Committee for Standardization in Hematology and Clinical Laboratory Standard Institutes. The tripotassium ETA, on the other hand, is the liquid form. You call this one your sequestrine. Okay, then we have here the application of the ETA. So ETA is basically used here for routine cell count for the CBC for our hematology tests. For routine cell count like your WBC count, your platelet count, so ginagamit ang sa EDTA ilalagay ang blood natin for even for the CBC complete blood count. Another one, your EDTA could also be used here for blood smear preparation, provided you prepare your smear in the blood collected in the EDTA within 2 hours of collection process. Because again, within 2 hours of collection process, able to preserve well the morphology of your different cells here in the EDTA. Kasi pag more than 2 hours, ang mangyayari niyan, magkakaroon ng morphology distortion ang ating mga cells natin. So, dapat pag gusto mo gawa ng blood film, blood smear with the EDTA, dapat you need to prepare that one within 2 hours of collection process. Your EDTA, hindi ginagamit for coagulation studies. So, when you are testing for activated partial thromboplastin time, prothrombin time, so, ang blood natin dapat hindi EDTA tube. Because again, your EDTA is not able to preserve here your factor 5. Factor 5 is your coagulation factor. So, since hindi niya na-preserve ang factor 5, that will deteriorate ang factor 5 sa kanya, which is a coagulation factor. So, magkakaroon ng decreased result. If then again, if your blood has been collected in your EDTA, so dapat hindi siya ginagamit for coagulation studies. Another one, the EDTA also inhibit your thrombin fibrinogen complex formation. So, therefore, hindi siya pwede. Another disadvantage of the EDTA, your EDTA collected blood could induce here platelet satellitism. So, we just assume these are your platelets. This is your neutrophil. So, your platelet try to surround your neutrophil. It form a satellite. So, you call it once your platelet satellitism. Ano magiging effect ng platelet satellitism? So, pag nag-analyze tayo ng blood, when we are performing the CBC, using your Hema analyzer, kasi pag Hema analyzer, ginagawa lang natin, we just feed the blood sa Hema analyzer, tapos ang Hema analyzer lang ang mag-count ng mga cells natin. And based on that, your Hema analyzer, mga automated instrument natin, will identify the different blood cells in our body. Identify the different blood cells in your blood sample depending on their size. So like, kung maliit ito, ay okay, platelets. Pag malaki ito, ay WBC yan. However, here, pag nagkaroon ng platelet satellitism, ma-platelet mo, mag-stick dito sa neutrophil, ano mangyayari? So, ang machine mo will not identify this one as the platelets. Kaya, ang magiging count ng platelet mo mababa, that's your thrombocytopenia. Okay, bakit mababa? Kasi akala ni machine hindi ito platelets, but rather akala niya ay WBC, which is the neutrophil. So, bababa ang kakount niya ng platelet, dadami ang kaniyang neutrophil or kaniyang WBC. That become here your pseudo-leukocytosis. Pinya is mababa, cytosis is mataas. Okay, so leuko because leukocyte, platelet, thrombocyte, that's other name for that. Okay, para ma-prevent that one, again, nangyayari lang ito pag machine ang ginagamit natin. Although, pag manual naman, when you try to identify this one under the microscope, bibilangin mo pa din siya isa-isa. However, again, if ang method na ginagamit mo is the automated instrument, so yan ang mangyayari. To correct for that, you could recollect the blood sample. However, here you collect the blood again in the citrate. And whatever the result of your automated analyzer with the WBC count and the platelet count, you multiply your result by 1.1. Mako-correct na siya. Okay, another one. Again, your EDTA tube here could be used primarily for doing the CBC or your complete blood count. So, complete blood counts includes the following like your WBC count, RBC count. Okay, so anong guidelines natin dito? Again, the EDTA tube here could be used for doing those tests like your WBC count, platelet count, your ESR or your erythrocyte sedimentation rate in the blood collected in the EDTA up to 24 hours. Okay, pwede mo pa rin siyang gawin provided that you store your blood, okay, at 4 degrees Celsius, which is your refrigerator temperature. Like, for example, sobrang dami ng pasyente natin, so hindi mo siya lahat magawa at the same time or immediately or ASAP. So, gagawin mo yung ref mo na lang siya and then warm it before you try to analyze. Pwede pa rin siya up to 24 hours. It will still be ideal result pa rin siya, provided again that you ref your specimen within that one, within that time period. Okay, so we have your conditions. We have your insufficient EDTA. Pag sinabing insufficient EDTA, because remember here that, di ba, yung lahat ng blood collection tube natin may mga mark. Yan, kung saan tayo dapat, hanggang saan tayo mag-fill in ng blood sample natin. Kung saan siya nakamark, that will be the appropriate volume of your anticoagulant versus your blood. That's why you need always to make sure that you fill that one on the desired mark. Like for example here, what if you have insufficient EDTA? Ano ibig sabihin ng insufficient EDTA? Pag sinabing insufficient EDTA, insufficient ang ating anticoagulant, madaming ating blood sample. Hindi siya nasa appropriate anticoagulant blood ratio. Okay, so when speak about insufficient EDTA, so kung itong mark, nag-fill ka ng blood hanggang dito sa taas. So, sobra-sobrang blood, that's your insufficient EDTA. Sobrang blood, konti ang anticoagulant natin. That's your insufficient EDTA. Pag sobrang blood, ano mangyari? Magka-clot ang ating blood sample kasi again, kulang ang ating anticoagulant to prevent the clotting process. How about your excessive EDTA? Excessive EDTA is madami kang EDTA or anticoagulant, konti yung blood. So, that's occur here in a short draw. So, what do you mean by this one? Itong mark na dapat mag-fill ka ng blood hanggang dito lang. Okay, hanggang below the desired mark ka nag-fill ng blood kasi kulang ang blood mo. It become excessive EDTA, kulang yung blood, madami kang anticoagulant, excessive EDTA, short draw. Short draw of your blood sample. So, pag madami ang anticoagulant, more than your blood, ang mangyayari ay it would result here to the shrinkage of the RBC. Liliit ang mga RBC natin. What will be the effect of that? Pag lumit ang red cell natin, okay, bababa ang hematocrit natin. Remember that your hematocrit, pag gumawa tayo niyan, this represent here your packed red cells natin. So, kung ito ang packed red cells natin, okay, so ito dapat, since lumit ang red cells ng RBC natin because of this excessive EDTA, so bababa. Instead na yan, so hanggang dito na lang ang PRBC mo because na lumiit ang size niya. So, therefore, this is equivalent to your hematocrit concentration. Okay, so bababa ang hematocrit na result natin because of your excessive EDTA. For the ESR, erythrocyte sedimentation rate, bababa din ang ating erythrocyte sedimentation rate. It's because here, erythrocyte sedimentation rate is the rate of the red cells. Pag tinest natin ito yung rate kung kailan magsisettle ang red cells natin. Pag nilagay mo sa tube ang red cells ng blood natin, ganyan. So, di ba magsiseparate ang mga RBC pababa. That's your erythrocyte sedimentation rate. The first step in the erythrocyte sedimentation rate, para bumaba sila, kailangan nila magkaroon ng rouleau formation or the stack of coin arrangement. So, ito. Because normally, dapat ang red cells natin, they are negatively charged. Pag negatively charged, they will not stick to one another. They try to push one another. Pero pag you just let them na mag-settle here, so the first step would be the rouleau formation kasi nasira ng negatively charged and then try to settle here. Okay, pero pag you have your short draw, because the shrinkage of the red cells, okay, hindi sila mag-rouleau formation. Pag hindi sila mag-rouleau formation, hindi sila mag-settle. And therefore, decreasing your ESR result here. So, again, that will be the effect of your excessive EDTA or too much anticoagulant compared to the blood volume. Okay, the next anticoagulant, we have here the citrate. The citrate prevent the clotting process by combining with your calcium to form here soluble complex. So the citrate here, we have a concentration 3.2% or the buffer citrate or that one or your 0.109 molar. Okay, there are two formulation for your citrate. One is your light blue. Another citrate is the black top tube ng citrate. Okay, the light blue here is 1:9. Pag sinabing 1:9, 1 part ni anticoagulant and 9 parts ni blood. Or like 1 ml ni anticoagulant, 9 ml ni blood. So that's your 1:9 anticoagulant blood ratio for your light blue na citrate. Again, the light blue is ideal for coagulation studies. Coagulation studies includes your prothrombin time, your activated partial thromboplastin time. This is ideal here for coagulation studies because again, your citrate here could be able to preserve well your coagulation factor 5 and factor 8, which are your coagulation factors. So, making that one as an ideal na anticoagulant here for coagulation studies. Unlike your EDTA, di ba, hindi siya nakakapag-preserve ng coagulation factors and therefore hindi siya ginagamit for coagulation studies. Another one, your light blue here is also being used here for platelet aggregation tests. On the other hand, another formulation of your citrate is 1:4. 1:4, 1 part ni anticoagulant and 4 parts ni blood. Again, that would have here your black top tube. That is ideal for the ESR na method, specifically the Western grain. Yung the green na grain. Okay, the next one, we have here the oxalate. So, oxalate prevent the clotting process by binding to your calcium to form here the insoluble calcium oxalate salt. Okay, so we have the formulation for oxalate. 0.5 ml of the oxalate is enough to prevent the clotting process of your 5 ml of your blood. So, other name of your oxalate, we have the balanced oxalate or the double oxalate. Bakit tinawag siyang double oxalate? Because again, this is made up of two oxalates, potassium oxalate, and we have also here the ammonium oxalate. Pag gumawa ka nito, 2 parts ni potassium oxalate and 3 parts ni ammonium oxalate. Pag sinabing 2 parts, like 2 ml, 3 ml, parang ganon. That's the volume, the ratio of the weight of your potassium oxalate, ammonium oxalate, when you're preparing your oxalate. Okay, so this is also called here as the balanced oxalate because your potassium oxalate try to shrink the RBC, whereas your ammonium oxalate try to swell the red blood cells. Other name of your potassium oxalate is your Paul Heller's, and we have your ammonium oxalate. Other name for that is your Winthrop oxalate. Okay, then we have here your heparin. So again, heparin is the only anticoagulant not related to destruction, neutralization of your calcium, but rather is involved here acting as your antithrombin. So heparin is used for osmotic fragility tests. And this is not ideal here for the blood smear preparation because again, blood smear collected or the blood prepared or the blood smear prepared from your blood collected through your heparin, if you try to stain that one with your Romanowski stain, magkakaroon siya ng bluish-black na background. So, pag sabing bluish-black na background, medyo mahirap ang meaning to say, hindi ganun kaganda ang magiging background ng smear mo when you try to examine that one under the microscope. Medyo madilim siya, so mahirapan ka mag-identify ng morphology ng mga cells natin. Therefore, making this one as not an ideal here for the blood smear preparation. So, EDTA ang ginagamit natin for the blood smear preparation. And lastly, we have here your fluoride. So again, this one is anti-glycolytic agent to prevent the glycolysis for the glucose termination. Okay, thank you.